Hey guys, so we are on the back page of day 3. Back page of day 3 here for part 2. So this is going to have to do with word problems and solving. So word probs and solving in general. 13 and 14 are going to be our word problems. Then we're going to get in some expressions or inequalities written with words. And then we're going to transition straight into solving and graphing. So I'm looking forward to this day. This day is going to be short, but it's going to be a lot of variety. So let's check it out. So first off, we've got 2 word problems. Remember our steps. Step 1, we need to find the variable. Let's see. A cheerleading squad earns $5.50 per car washed. How many cars does the squad need to wash, in order to earn at least $77? So there's our key. I'm going to go C. That is number of cars. Step 2. We need to find our total. And I think they spelled that out for us right here. $77. So something's going to have to add up to be $77. Now here's the thing. Step 3, we need to fill in the inequality with variable and numbers. So step 3, we need to fill in the inequality with variable and numbers. So let's see, how much are they making? So they earn $5.50 per car washed. So that would be $5.50 times the number of cars they wash. Well, we call that C. So $5.50 times C. And then how's that going to compare to $77? Well, they need to earn at least $77. So wouldn't it make sense for them to shoot for greater than or equal to $77, right? You don't want to undershoot it. You want to go greater than or equal to what you're trying to go for. And so when we go to solve this, we divide by $5.50. And how many cars is it looking like they're going to have to wash, guys? Looks like they're going to have to wash more than or equal to 14 cars. So 14 or more cars before they reach that $77 limit. Now this next problem, I noticed there was a little bit of a typo. So we are going to move past this one. So you guys get off one less word problem today. So yay! Now, what compound inequality represents each phrase? Ooh, we get to write compound inequalities. I love it. We get to write compound inequalities here. Now remember, when it comes to compound inequalities, we have and we have or. Or means we're going to have, x is less than 3 or x is greater than 7. Something where x can't be both these things. It's one or it's the other. With ands, we have, A is going to be bigger than 3, but A is also going to be smaller than 10. Something like that where we're saying, hey, A is bigger than this, but it's smaller than 10. So let's take a look here, guys. All real numbers, so we'll call that a variable. I'll call this, I'll go V. All real numbers that are greater than 1. And then what's the magic word you see here? And less than 5. Okay, so we've got V, and we're told V is going to be greater than 1. But what else is it going to be? And less than 5. So v is greater than 1, but v is also less than 5. I'm going to let you guys try number 16 for me. See what you guys think about that one. All right, check this one out, guys. All the numbers that are less than 10, here's our word, or greater than 15. So we know we're going to have a situation like this up here. So I chose C. C is less than 10 or greater than 15. So hopefully you feel pretty good about that one. That one's not too bad, is it? Not too bad at all. So now I'm going to give you guys a chance to practice with me some a little bit more interesting problems. These are compound problems. We got and or problems right in here. You even can see the word or right there. These first two are and problems, though. So how do we solve? We got to find the graphs and the solutions here. Well, we look for where the variable is. There's x. What's attached to it? A plus 2. So to solve for x, we need to get it by itself. We subtract 2. Now, where else do you think we subtract 2? From the left side and the right side. We got to keep this whole thing balanced. So you subtract 2 from the middle, the left, and the right. So negative 4 is less than x, which is less than or equal to 5 minus 2. That is 3. I go to graph this, negative 4, 3. And see if you can complete this graph here, filling in which point needs to be filled in and shading where it needs to be. Go ahead. Okay. Looks like we need to fill in 3 because x could be less than or equal to 3. And speaking as less than, we're shading to the left. But then what happens once we hit negative 4? X is greater than negative 4. Oh, so we go back to the right. We're stuck in the middle. There's x. Stuck in the middle. That's what makes this an and problem. X could be 2. It could be 1. It could be 0. There are a lot of numbers that fit both this criteria. Let's do one more together here, and then I'm going to let you guys try one, and we're going to be ready to wrap up. Let's look at an OR problem. So I like OR problems because we treat them kind of like normal inequalities. We just solve them separately. Solve each piece. So we just solve each piece. There's a piece, there's a piece. So how do we solve this first one here? Well, 2n minus 1 is less than negative 3. Let's start by getting everything away from n. So we add 1. 2n is less than negative 2. Divide by 2. And I believe you get n is less than negative 1. Now let's check this one out over here. So we subtract 2. I'm going to bring this over here. Negative 3n is less than, that cancels. Negative 4 and negative 2 is negative 6. Then we divide by negative 3. Bada boom. Oh, and shoot, we just divided by a negative. So what's going to happen to our inequality sign? It's going to flip. Negative 6 divided by negative 3 is positive 2. So we're saying, and we said this is an OR problem, we're saying n is going to be less than negative 1 or n is going to be greater than 2. Let's see what that graph looks like. So, it's Halloween. We got the lights turning off. So we're going to have a point at negative 1. We're going to have a point at 2. Will either of these be filled in, less than, greater than, no equal to? So nope, open. And if n is less than negative 1, that means we're shading to the left. And if n is greater than 2, that means we are shading to the right. So you see how these two shadings never intersect? That's why this is an OR problem. So last problem. I'm going to let you guys try to solve number 2. It is an and problem. And then see if you can give me the graph. And we'll finish with some homework. Okay, we subtract 2 from the middle. That means we have to subtract 2 from the left and from the right. So negative 4 and negative 2 gives us negative 6. Y in the middle, negative 10 minus negative 2 is negative 12. And if y is bigger than negative 12, follow the arrow. Since y is on the left, we're going to the right. But if y is less than negative 6, that means we have to go from negative 6 to the left. This is an and problem. Yep. So y is in the middle. It's negative 10, negative 8, negative 7. It could be a bunch of different numbers. And so as we wrap up, your homework will be number 1 and number 2 here, along with the delta, the little mini delta that I posted earlier this week, if you haven't already done it. Thank you, and I'll be talking to you guys soon.